Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be talking about the Calculus 2 concept of infinite limits. When we talk about infinite limits, we're talking about one of two cases. We're either saying that there's an infinity in the bounds, like this, or we're saying that the function has like a vertical asymptote or something in the middle of the function. Like if you think of this function, 1 over x, it's got a vertical asymptote at 0. You can't take the integral from -2 to 2, not without using the strategy of infinite limits. So that's what we're going to be doing today. Let's get started with our first example. We have the integral from 0 to infinity of 1 over x squared plus 1 dx. Now, in case you don't know what this question's asking, remember that integrals are basically finding the area under the curve. If we know what this function looks like, 1 over x squared plus 1, which I do, but you don't have to, the function looks something like this, kind of like a bell curve from statistics. And if we're finding the integral from 0 to infinity, then we're saying what's the area of this portion of the graph right here. And technically, since it's a horizontal asymptote, there will technically always be area there, but it could converge to an actual finite value, which we're hoping it does. So in other words, how do I solve this? First thing I'm going to do is I'm going to change this infinity into a limit. Watch how I do this. I'm going to do the limit as t approaches infinity of the integral from 0 to t of 1 over x squared plus 1 dx. Technically, you cannot have an infinity in your limit, so the first thing you should do is replace it with the limit as t goes to infinity. It basically is the exact same thing, it's just better notation. The next thing we're going to do is we're actually going to solve this integral. Luckily, hopefully, you know this, I know it. It's the arctangent of x, pretty easy one. And so that means I'm going to write arctangent of x evaluated from 0 to t, and I can't forget this is the limit as t goes to infinity. So then plugging in here, I'm going to get arctangent of t minus arctangent of 0, and again, this is still the limit as t goes to infinity. And now we need to know what the arctangent of infinity is. If you don't know what that graph looks like, arctangent is a function that has horizontal asymptotes at -pi/2 and +pi/2. And basically the graph kind of snakes like this, passes through 0, and then approaches pi/2. So if we're looking at positive infinity, I would say we're approaching pi/2. So that means I have pi/2 minus the arctangent of 0, that is just 0. And so then my answer is going to be pi/2. In other words, if I scroll back up to my original function, all this blue area right here adds up to pi/2. Pretty cool. And now let's look at a couple more examples. For this next one, I have the integral from 0 to 1 of 1 over root x dx. If you don't know what this function looks like, this function basically looks like half of the function 1 over x, except you can't have the negative half because you can't have negative square roots. So the graph looks something like this. And I want to find the integral from 0 to 1. So basically this area right here. And again, you'll notice there is an infinite limit here because, well, we're going to infinity because of the vertical asymptote. So the first thing I'm going to do is I'm going to say I can't actually plug in 0. That is where the limit's going to go in. So it's going to be the limit as t approaches 0 of the integral from t to 1 of 1 over root x dx. Hopefully you remember how to solve this integral. It's just a simple Calc 1 integral. First, you turn it into x to the -1/2. And now we're going to use a power rule to actually solve this integral. -1/2 plus 1 is +1/2. So it is going to be x to the +1/2 divided by 1/2. Although I'd never write divided by 1/2. Instead, I would just say times 2. It's the same thing and it's way better. And then we have to evaluate this from 1 to t, where our limit is as t approaches 0. So it's going to look like this now. It's going to be 2 times 1 to the 1/2 power minus 2 times t to the 1/2 power. And remember, we're going to plug in t for 0. And also remember that 1/2 power just means square root. Like this is 2 root 1 minus 2 root 0. This is no problem at all. Looks like we're just going to get 2 minus 0, so the answer is 2. And we're done. That's it. By the way, let's just say hypothetically that instead of this problem, you had something like this, and we're plugging in 2 over root 1 minus 2 over root 0. In other words, there's still a 0 even after you took the integral and everything. Well, if you ever get anything like this, then you would say dne does not exist. Or maybe you'd say infinity or negative infinity, depending on the problem. It's also for that reason that sometimes you'll see the limit as t approaches 0 plus, in other words, from the right side, because this graph is from the right side of 0, not the left, because it doesn't exist there. And now for one more example. Here we have the integral from negative infinity to positive infinity of 2x e to the negative x squared dx. Now, two things that trouble me about this one. Number one, I have no idea what this function looks like. And number two, since I have negative infinity and positive infinity, it means I'm going to need two different limits here. Very annoying. Let's say I have the limit as t approaches infinity, and then I'll also say the limit as v approaches negative infinity. And you can choose literally any letter you want. I chose v because it's the letter after t, and of course I skipped over u because I'm actually going to need a u substitution for this integral. Always thinking 5 steps ahead. So then that's going to be the integral from v to t, negative infinity to positive infinity, of 2x e to the negative x squared dx. Like I said, this will be a u substitution where our u is the exponent, negative x squared, du equals negative 2x dx, and then that means dx equals du divided by negative 2x. So then plugging in this integral, it's the integral from v to t of 2x e to the u times du over negative 2x. As you can see, the 2x's cancel out. This negative sign will move out in front of the integral. And now I just have negative integral from v to t of e to the u du. I'm getting lazy with my limit notation. Technically, there's supposed to be two limits right here, limit for t and limit for v, although I'm getting lazy, so I don't really care that much. And this is going to become negative e to the u, where u is our negative x squared, and then we're going to evaluate this from t to v. Remember, t is infinity and v is negative infinity. So then to write out the whole thing now, t approaches infinity, and then second limit, v approaches negative infinity, of negative e to the negative t squared, double negative makes it plus e to the negative v squared. And the nice thing here is that since both infinity and negative infinity are going to be squared, it's the same thing. It's essentially negative e to the negative infinity plus e to the negative infinity. Because again, even if you square negative infinity, it becomes positive. So in other words, negative infinity squared becomes that. Hopefully you all see that. And then if you're wondering, do these two things cancel? The answer is yes, the answer will be 0. But I do want to tell you that even if they didn't cancel, this wouldn't necessarily be a problem. The reason why is because whenever you have a negative power, it's really in the denominator, like that. So technically we have this, and this is not infinity or negative infinity. Both of these are just 0 anyway. It's 0 plus 0. Final answer is 0. If you had e to the infinity plus, or really minus e to the infinity, and these were both positive powers, I would say that since they're the exact same thing, they cancel. But if we had something like e to the infinity minus some constant 10, then the answer is going to be infinity, or dne does not exist. I'm just warning you if you ever see that case, because that does happen. So that's all the examples I have for today. The answer for that last one was 0. So thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.